I will start with introduction.
The aerospace industry covers things like aircraft, spacecraft, satellites, and even missile or drones. Basically, anything that flies in the air or space. Aluminum is one of the most used material in this industry because it's lightweight but still strong, which is super important when designing things that fly. For example, in aircraft like Boeing 737 or Airbus A320, aluminum makes up about 70% to 80% of the structure, including wings, body, and landing gear. In space application, aluminum is also used in rockets and satellite parts because it can handle high pressure and extreme temperature. Being like, aluminum is also resistant to rust, easy to shape and recyclable, all of which make it ideal for building safe and efficient aerospace system. That's why aluminum is still the top choice in many parts of the aerospace world. From commercial planes we fly in to space mission reaching beyond Earth.
Assalamualaikum, my name is AQIF HARRIZ. Ever wonder how those planes soaring and rockets launching into space? No, it's not magic, it's science. And at the heart of it all is an incredible metal you might take for granted, aluminum. So let's know more about aluminum, shall we?
Aluminium is the third most abundant element in Earth's crust, but pure aluminium is soft. So how does it become a powerhouse material for aerospace? The secret lies in alloying. By adding small amount of other elements like copper, zinc, magnesium, and lithium, engineers transform soft aluminium into super strong alloy.
It's much stronger.
What makes it truly special? It's incredibly low density. Imagine material that are as strong as some steels, but a fraction of the weight. Delving deeper, aluminum's magic is rooted in its crystallography. Pure aluminum has a face-centered cubic structure. This dense atomic arrangement makes it strong and stable while giving it many slip systems, allowing it to deform without breaking. Perfect for shaping those complex aircraft parts. The aerospace industry primarily relies on two star players in the aluminum alloy family, the 2000 series and the 7000 series. The 2000 series, with copper as its main alloying element, are known for their very high strength, achieved through precipitation hardening. They are perfect for aircraft skin and structural components, providing an excellent strength-to-weight ratio. Then there's the 7000 series, primarily alloyed with zinc, often with magnesium and copper. Alloys like 7075 and 7050s are the absolute strongest. Their unparalleled strength and fatigue resistance makes them essential for critical parts like wing spars and landing gear. Alright, we've seen how aluminium goes from a soft, abundant metal to a strong, lightweight wonder through alloying. But why is this transformation so epic for planes and rockets? It's all about unlocking those critical properties. So get ready to discover how this precise property makes aluminum the ultimate material for pushing the boundary of flight.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is LUQMAN Al-Hakim bin ZUHABRI, and I'm going to present to you guys about the critical properties of aluminium alloys. There are different types of aluminium alloys used for different parts of a plane. For example, there is 2023 T3 that is used on a plane's body and wings because it is strong and can handle repeated stress very well. It is perfect for parts that face pressure difference and changes during every flight. Second example would be the 7075 T5 alloy. It is actually one of the strongest aluminium types. It is usually used in military planes for parts like landing gear, wing support. Since it can rust more easily, it usually have to get a protective coating, yes, as such. And even though the aluminium alloys is not used greatly for carrying electricity, sometimes they are still used for things like grounding or blocking signal. So in summary, aluminium alloys are still very important in making aircraft. Each type is chosen carefully depending on what parts it needs, whether it is strength, flexibility, or rust resistant.
Hello, I'm Non and I will continue from here talking about the advantages of aluminium in aerospace application. Have you ever wondered what airplanes are made of? Let me show you something interesting. It's all about aluminium. So why aluminium is important in planes? Imagine a plane fly high in the sky. What helps it stay light, strong and safe? One big reason is aluminium. Aluminium is very light but also very strong. A lighter plane uses less fuel, flies faster, and carries more weight. Some types of aluminium are almost as strong as steel, but only half of the weight. And we also know that planes fly through rain, snow, and changing air pressure. Aluminium is great because it doesn't get rust easily. This helps plane parts last longer and keep passengers safe. Also, aluminium can be easily bent and shaped into many parts, like wings, panels, and more. That means planes can be built faster and by lower cost. And do you know also that aluminium helps control heat from engines and electronics because it moves heat away quickly? It also helps in electronical system by carrying electricity and protecting other parts. Another advantage is that planes take off and land many times. Aluminium can handle repeated stress without cracking. That is why it's used in wings, landing gear, and key parts of aircraft. At last, I want to say that aluminum is 100% recyclable. We can melt it and use it again without losing strength. It also needs less energy to recycle, which help protect our planet better than other material. Compared with the other options, steel is too heavy, titanium is expensive, composites are hard to recycle, but aluminum is light, strong, cheaper, and easy to reuse. So the next time when you see plane, remember aluminum is a hidden hero that helps to fly. Aluminium, the backbone of modern aviation, lightweight, strong, and seemingly perfect for flight. But beneath this shiny surface lies a darker truth. Today, we uncover the hidden challenge that threatens every aircraft in our skies.
The first enemy is heat. Pure aluminum melts at mere 660 degrees Celsius, dangerously low for aircraft engines that burn at over 1000 degrees. Even advanced aluminum alloy can only handle 500 degrees before fading. But it's not just extreme heat. Every flight subjects aluminum to brutal temperature swings, from -70 degrees at cruising altitude to +150 degrees near engines. This constant expansion and contraction creates invisible stress fractures that could spell disaster. The second threat lurks in the air itself. Salt from coastal airports attack aluminum like acid, creating tiny holes that spread like cancer through the metal. Even worse, when aluminum touches other metals, steel bolts, titanium fittings, it becomes a sacrificial lamb, corroding faster to protect its neighbors. Finally, aluminum fights back during construction. Its exceptional heat conductivity makes welding nearly impossible. The metal still heats faster than welders can apply it. When mechanics try to bend it into shape, aluminum hardens and springs back like a defense spirit. Despite these challenges, aviation engineers continue their battle against aluminum's limitations. Through innovative alloys, protective treatments, and careful design, they keep us flying safely.
Now, let's take a look in development and recycling of aluminum in aerospace. Recent scientific work of aluminum in aerospace. Why recycling aerospace aluminum is important? The aerospace industry needs more sustainable manufacturing. High-performance materials like aluminum alloys are now being recycled, and focus is on 7075 aluminum alloy commonly used in aircraft. Main challenges in recycling. First, sorting scraps. Aircraft scraps are often mixed with other materials. This makes sorting difficult and reduces reuse value. Second, impurities in melt. Large surface area of scraps leads to more unwanted particles in the melted metal. affects the purity and quality of the recycled alloy. Types of aerospace aluminum scraps. First, aircraft dismantling scrap comes from old aircraft. Second, machining scrap, leftover from manufacturing. Key findings from the study. Recycled aluminum melts can now reach similar purity to primary aluminum. Microstructure and strength of recycled alloys should match those of primary alloys, promising result for airworthiness certification of recycled materials. In-depth analysis of development and applications of aluminum alloys for aerospace industry. Contemporary challenges and drivers since 2000s. Modern demands: higher strength to weight ratio, lower density, greater fatigue life and damage tolerance, better toughness and corrosion resistance. Second, evolving material landscape, rise of new high-performance materials, pressure on aluminum alloys to innovate and stay competitive.
I'll now conclude our presentation on aluminium in the aerospace industry. From this project, we've learned that aluminium is a key material used in both aircraft and spacecraft, mainly because it's lightweight, strong, and resistant to corrosion. It helps make planes safer, faster, and more fuel efficient. We also found that different aluminium alloys like 7075 and 2024 are specially chosen depending on what part of the aircraft they are used for, whether it's the wings, fuselage, or even inside space shuttle. This topic helps us understand how material selection in engineering isn't just about the strength, but also the factors like weight, cost, and environmental impact. So overall, we've seen how aluminium plays a huge role in real-life aerospace application, and it will continue to be an important material as the industry grows and improves in the future.